Hello, and welcome to another episode of the how-to series for the Scuttlebot Dev Kit. Today we're going to be walking through the actual code on the device side. So this is going to be in Arduino, and we're just going to walk through so that you know basically what the different aspects of the code actually does. So to start off, we're going to open up our Arduino IDE just so that we can actually look in the code. This is where I prefer to work most of my stuff out. If you want to be using VBasic or another tool, that's up to you, but this is what I'm showing you. The core or the main section of our code is Scuttle Shell, and you see that I have a bunch of different modules and a bunch of different headers that all work together. Scuttle Shell is the orchestrator. It is basically the central piece of code that is telling everything what to do and handling that. The way that this device works is the hardware is primarily a communications hub. It's a communication server. So it will be setting up the means and monitoring those means of communicating with the PC, waiting for signals from the PC, executing those commands, as well as receiving audio data from the PC and sending the PC video data. So those are the main things that we have set up right now. The way that we set this up, we're just going to go over this at a really top level. We're not going to bother with talking about all the different libraries, but these are the libraries that you need, some of which are, actual published libraries, some of which are custom. You'll see us kind of going through all that. The main thing that you're going to be seeing is that we're going to be talking to a couple of different modules. We're going to be talking to our Wi-Fi module, our action item module, which is our Scuttle Move, our Scuttle Cam, our Signal Checker, and our Scuttle Sound. So those are our 5 modules that we're playing with, and so we set up those classes first. We set up an async web server, so that's really going to be how we are, that's basically the web server that we're communicating with. Next, you'll see me prepping to set up 3 different WebSocket connections. So again, we're using Move, we're using Camera, and we're using Sound. And setting up the commands that we will be using to talk to those different modules. So they're just different things that we're seeing happening. There'll be add handler, there'll be on events, different things like that. So finally, in this section of the code, you're going to be seeing our setup. So actually, this is not finally, but this is the final prep thing that we do. So we basically, you see us setting everything up. We start our serial port, we set up our Wi-Fi, a couple of different steps in setting up our Wi-Fi. Then we go ahead and start our signal checker, our Scuttle Cam instance, Scuttle Sound, and our action item or move. So these are basically how we kick everything off. Our loop is empty. The reason for that is we do almost all of our tasks, in fact all of our tasks are set up in the free real-time operating system that comes on ESP32. This is a way that we get all of this cool stuff to be happening at once instead of waiting for one process to finish. So this lets us do all the parallel operations. So our thing that we're setting up here is this is where we are listening for any commands that are coming over our WebSocket, on the WebSocket command, I should say. So that particular instance is waiting for different signals to come in. As things come in on that command WebSocket, there can be connections, there can be disconnections, and there'll be data. And when it gets data, it first kind of starts to parse it out and see what kind of data it is. Is it a command? Is it a message? If it's a command, it knows that it's received basically data from the controller of some sort, whether that's coming from your Xbox controller or it is setting up something based on its own operations. So it'll be sending that in the same format, which is really basically a bunch of binaries and a few analogs. Depending on what it gets, it will be turning things on and off. So for example, if button 9 has been pressed and then released, it knows to turn on the camera or turn off the camera. Similarly, there's other things that we'll go through there. There is instead of a command, you can get a handshake, and that is just your initial connection with your server, or between the server and the client. So you'll see some of that happening. You see basically some ping pong going on there. And similarly, we set up a WebSocket for the camera. And that's really just straightforward, and you're listening for it to connect or disconnect. Now in this case, you will never be getting data from the PC, so you don't see that coming in. We do, however, send data from our camera, but in this part, we're not planning on receiving data from the PC to the hardware device. Similarly, we have our WebSocket for sound set up here. Again, what happens when it connects, what happens when it disconnects. Is it a binary, which is what we expect? There's just different checks that it's going through, so it knows what to do with that sound data. So in all of these, once it gets data, it generally will send some sort of command to the various modules. So we're going to go to that. But before we go to that, we're going to look at signal check. Signal check is actually called by Wi-Fi manager, or excuse me, by the Wi-Fi module. And it's very straightforward. All that signal check does is the header. You can see how I set up the class there. And all it's doing is it's sending us the dB of our Wi-Fi connection strength. So that's kind of important. It's a good metric for us to keep our eyes on. So let's go into the Scuttle Wi-Fi. Here's my header setup. You can see that I've got set up for public and private. And let's just kind of go through the basics of this. So you're going to see a bunch of different class calls here. For example, Scuttle Wi-Fi is Scuttle Wi-Fi, and your different different modules or subroutines here. So we have our save credentials or get credentials. That is what we use when our config login information does not work. You can see our begin. Let's go, hey, this is how we connect to our Wi-Fi. These are all the steps that we're going to take when we are connecting. And you kind of just see it go through that process. And this is how we set it up so that it first checks for the Wi-Fi based off of the config.h file. Then it will go ahead and try to use any stored data that it may have gotten from a previous AP configuration setup. And finally, if it still can't find anything, it will go into AP mode, and it will set up that GUI that you can log into and give it your Wi-Fi information directly. This is all the steps that you saw in our how-to number 2, which you can go back and see what was going on. So this is the code that actually makes that all happen. Here we've got just some basic stuff as we initialize the Wi-Fi manager. So that's the AP procedure that we set up here. So when it's actually failed, it just kind of goes with that Wi-Fi manager. Set up MDNS. So this is something that we did just because we don't want to have to look up the IP address every single time, because it's going to be different on everybody's servers. We set it up so that it will just look for a common name. It will set it up, that it broadcasts its name. That name is Scuttle Host. And that's stored under the host name variable. And so that's what you see going on here for the MDNS. The OTA is set up here, and you've seen us use the OTA, the over-the-air updater. And that is, you saw that also in how-to number 2. So finally, you see us doing all of these steps, and one thing that I do want to point out is you see this void that is called basically early on in the code, and it's create tasks. And this is where we are creating all of our individual tasks that are operating off the free RTOS. So what you'll see is basically you'll see a similar format every single time. It's like, what is the function? What is the name? How much memory are we reserving for it to do this thing? Are there any additional input parameters? Now, the important one is priority and the core. Priority, the higher the number, the higher priority it gets. So if there is a time where multiple things are trying to run at the same time, it will prioritize that one over other ones. So that is a number that will range from 1 to, I believe, 10, and you want to be reasonably conservative with that. Core is the core that we're operating on. Because the ESP32 that we're using is a dual-core chipset, we have our choice between 0 and 1. 0 is where most of the automated functions are happening. So that's where we kind of want to put a lot of our stuff that maybe might not be super resource intensive. So you see me setting up things up on this level with that 0 core. Now let's go ahead and actually look at a task. So earlier I believe that we've set up this flasher task. What does that flasher task actually do? So this is our flasher task. And this is going to be similar for any task that you see set up. You see a while true. That means it's doing this all the time, sort of. We'll go through what that means in just a heartbeat. But you basically see it's going through, and it's basically monitoring, checking if we are actually connected. Do we still have a client? If we don't, we'll take some steps. If we do have a client, we'll do something else. In this case, you're seeing us control the flash. So basically the LED. It will give us a single LED every 3 seconds. If it's looking for a client, it will give us a double if it has a client connected to itself. So that's what's going on there. And again, that 3 seconds, we will go ahead and send out a heartbeat. So you see that here. So every 3 seconds, we're invoking this heartbeat setup. That's down here, where it's like we are actually broadcasting our signal strength as well as some memory data. So that's really kind of a debug factor. We may change that, but right now I've got that set up to monitor the heap sizes. So when we've allocated that memory size, so that's considered a heap, and we can look at that task and compare that to the amount of memory we have available. Just some good stuff that we can do there to monitor how everything's operating. The one thing that we skipped over was our handshake, and that handshake is really just a real quick, here's my name, here's my ID, and that's just kind of a formality that I do with the PC when that client first connects. So that's what's going on in Scuttle Wi-Fi. For Scuttle Move, again, very simple header setup, and what we're doing here, we set everything up, set up our Scuttle Move class, set up our connections to our servos. So if you haven't figured out by now, Scuttle Move is primarily where we are operating our servos from and how we're doing that. See us setting up our tasks, executing the movements, and that's going to be largely based off of what we received from our command WebSocket server, what kind of data that we actually got. So again, when I was talking about what numbers were being pressed, that's getting sent up here. And depending on what numbers are being pressed, it's going to take a different action. So the first thing is we're checking to see what mode we are in. So we can be in turret mode, we can be in tank mode, or we can be in R mode. and it will start to take different actions depending on which button is pressed or which joystick is being moved. So in this case, for example, we're looking at the turret, mode 0, and if it's getting either command 15 or command 14. So if those numbers are actually true, i.e. those that joystick is being pressed in those directions, it will go ahead and command it to rotate in one of those directions. Similarly, you've got your tank mode, and we do a little bit different there. I'm actually using analog, and I'm controlling each one separately from there. And finally, we've got car mode, and that got a little bit more complex, and I do a little bit of geometry to actually figure out what we want it to do, depending on where we've got it in there. Finally, we've got our mode change, where it's, if button 8 is pressed and released, change the mode. And our tilt, so that's basically being called by anything in common. So if ever, so for every mode, tilt is going to do the same thing. And then finally, this is how we attach, or actually we just operate our right wheel spin and left wheel spin. You see me attaching and detaching and attaching a lot. I found that was the best way to make sure that the actuators actually stayed off, which is appropriate for what we're doing in this design. So that's it for Scuttle Move. Let's go ahead and start to look at our Scuttle Cam. The first two things you're going to see is the index and the pins. You don't need to worry about this. That's the short answer. As long as you're using the same camera that we've supplied you with, the OV2640, this is good. You don't touch it. We're going to skip over config.h because we've already talked about that in how-to number 2. And so let's go ahead and look at our Scuttle Cam. See, I'm doing a couple of little different things for my header setup, but it's fairly similar to the other ones. And this is what we're doing here. So in this case, it's basically acknowledging that it's going to be taking commands from the command module, or actually Scuttle Shell. And the first thing we do is start to, excuse me, the first command that we've got here is, basically our cam task, where we're going to be sending data. We're setting that up first, just because, no real reason. I just decided to put it first. It's pretty straightforward. You just see me kind of broadcasting data as it becomes available, and we can get pretty good frame rate out of that. We've got our on and our on's command subroutine. So like when we are told to turn the camera on, it goes through this process, starts to initialize, checks your PS RAM, kind of goes through that, and then we've got our cam report, where we're double checking on our memory. So that's a debug function that we've got in there. And our camera off, where it's like, well, turn the camera off. So again, not rocket science here. Turn the camera on, turn the camera off, tell me what the camera's doing, and send the data if you've got data to send. That's what's going on there. And again, you see I've set up everything on tasks. Again, you're seeing every task have a v-task delay, and that delay is going to tell you how often you run that task. So for example, for the cam report, I'm only doing that every 3 seconds. So you see my v-task delay at 3000. So that's always in milliseconds, and that's what that means. Scuttle sound is pretty similar in the header, just kind of setting up some different things. And here's where that comes into play. So we set up our buffer here, and this is a rotational buffer. So basically we kind of start to work through the buffer, and then as opposed to rewriting it from scratch, we just kind of write over the data. So that lets us kind of keep rolling. It's a little bit better for real-time audio, which is what we're shooting for. This is important here, where you see that I'm actually setting up my I2S driver. That actually happens a little bit earlier. Getting some commands set up. One thing that you see is that what I've done here, and this may change, for the actual audio task, I've set that up on Core 1, and I've given it the maximum priority. And that seems to be working. These can always be tweaked and changed. So in this case, what we're doing is we're receiving the data from the PC, and then we start to process that data. So we put it in a temporary buffer, and then we move it over into the actual buffer that we send to the I2S. And the I2S is what connects to the speakers and actually plays the music. So we kind of go through that process. There's a little bit of communication back and forth on if it is ready for more data, so that the PC doesn't overwhelm it. The processor speeds of your PC are probably going to be a lot faster than your ESP32. So we have to put that in there. So you can just basically see some memory dancing going on here. Yeah, that's pretty much it. So we add to the buffer, like I was talking about. And then we also have the audio report, similar to what we're doing with the cam report, where it basically tells us how we're doing on its individual tasks. So there you go. That is the walkthrough for the Scuttlebutt dev kit command module code. Boy, it's a long name. But yeah, that's what's going on. I apologize in advance. I am not an expert coder, so some people are probably going to look at this and pull their eyes out a little bit. Preferably don't do that, go for pulling your hair out or something like that. But I understand that this is not going to be perfect code, but there's always room for improvement. So thank you very much for joining us. I hope this was helpful. Please make sure to like, follow, and share on our various social media platforms. And I look forward to talking to you next time.